Hello everyone, we are doing our project work in a no thermal power station. Our batch number is 18. This project is done by Chetan, Jayanta, Kumar, Nayak and Ananta, Narayana. Our project title is Improvised Cooling System. Introduction to endothermal power station. This endothermal power station started on 1970. It is one of the four major power plants of Tamil Nadu. It is a coal-based power plant. The total capacity of the endothermal power station is 450 megawatt. The 450 megawatt is divided into 5 houses, like 3 powerhouses of 110 megawatt and 2 powerhouses of 60 megawatt. The construction of 1000 megawatt powerhouse started in the year 2007. The total cost of the venture is 270 crores. Water is drawn from the Koeteli river, which can be also called as Buckingham Canal. Requirement of water for 60 megawatt power plant is 12,000 meter cube per hour, and for 110 megawatt power plant is 16,000 meter cube per hour. Abstract. As we know that the average lifetime of a thermal power plant is about 30 years, and after 30 years the plant load factor tends to decrease. The reason why the plant load factor decreases is because there is a deterioration of operating capabilities of the equipment. We found that one of the main reasons of this downfall of PLF is the existing cooling water system in the power plant, which uses polluted water from Buckingham Canal, due to which some damages occur in the equipment, which reduce the PLF. So basically our project deals with this problem in endothermal power station and its remedial measures and benefits after implementing such remedial action. Objective of our project. The main objective of our project is to provide effective and trouble-free cooling system to endothermal power station, to reduce the number of breakdowns, to increase the PLF, that is the plant load factor, from 50% to around 90%, and to reduce the maintenance and lighting up expenditure of the plant. Here in this part, we are showing some of the pictures of endothermal power station. In the left hand side, there is a picture of cooling water pump house, in which we can see that polluted water is used as cooling water system in the endothermal power station. And on the right side, there is a picture of Buckingham Canal water, in which the water is taken from the Buckingham Canal to the endothermal power station to several processes. If we closely notice in the right hand side, the picture contains other power plants also, which use the same Buckingham Canal water as the cooling water for their purpose. The above graph shows that the plant load factor is plotted in the y-axis and the years is plotted in the x-axis. You can clearly see from the graph that there is a decrease in the plant load factor over the years. That is, in the year 2007, the plant load factor was around 69%, and gradually it began decreasing, and in the year 2010, the plant load factor is around 49%. This is due to the number of breakdowns in the equipment which occur in the endothermal power stations, due to which the plant load factor, which can be defined as the average load to the peak load, is gradually decreasing day by day. So basically our project is to improve the plant load factor so that the efficiency of the company increases, efficiency of the production of power increases, efficiency of the overall plant increases. This is the water analysis report which we have done in the Chennai Metex lab. The water analysis report shows three main contents, that is the pH value, chlorine content and the ammonia content. Let's see all these data in detail in the next slide. Analysis of the sample water report. The pH value of the water is 6.7, which means that the water is acidic in nature. If the pH value is above 7, then we can call it a basic in nature, the water quality. The chlorine present in the water is 0.01 mg per liter, which forms acid as goes further. The ammonia present is 36.40 mg per liter, which forms acid, which damages the equipment at later stage. The presence of chlorine and ammonia is found by various testing methods like starch iodide titration method, pool test treat method, etc. The pH value can be measured by using pH meters available in the laboratory. Water required for 60 megawatt power plant is 10,000 meter cube per hour. In the right hand side, the diagram shows about the boiler tube failure. One of the main reasons of boiler tube failure is because of the chlorine content which is present in the water, due to which the boiler tube rusts and corrosion takes place on the boiler tube, and hence boiler tube fails. Now let us see the problem identification which are obtained by using polluted water system. This is the problem identification when we use polluted water system as cooling water system. So firstly, the polluted water goes into the condenser, and because it contains salts, chemicals, chlorine, etc., the condenser tube failure occurs. Then from the condenser, the water goes into the boiler, and the water contains chlorine which mixes in the boiler and gets heated. So because of which the boiler tube failures, and after the boiler tube failure, the entire shutdown of the plant takes place, and when the shutdown of the plant takes place, then the chlorine mingled steam will go into the turbine, which causes the turbine erosion, and the turbine tube failure occurs. And because of which the heat transfer reduction also decreases. Major problems by using polluted water as cooling water system. There are three major problems: condenser tube failure, boiler tube puncture, turbine blade erosion. The condenser tube failure occurs because the salt and chemicals present in the polluted water makes the condenser tube failure. In other words, we can also say that the chemicals which contain the polluted water are more powerful than the condenser tube material. Hence the condenser tube failure occurs. Boiler tube puncture. When the condenser tube failure occurs, the chloride enters into the boiler and punctures the boiler tube frequently. So the entire generation unit is lost for such shutdown periods. Turbine blade erosion. And during the shutdown period, the chlorine mingled steam causes erosion and the turbine blade corrosion. Hence the turbine blades are falling drastically. This damage occurs when there is usually boiler shutdown period. Present available techniques. These are the present available techniques which are used for avoiding many problems in the company. For avoiding corrosion, they use traveling screens and debris filters, but the debris filters are also getting choked often by the debris, so they need an operator who has to remove the debris again in order to flow continuously. Ferrous sulfide dosing. Presently, ferrous sulfide dosing is used, but this is not effective because there is a formation of thin layer inside the tubes that takes place in the condenser when we use this dosing. The third dosing is the chlorine dosing. By chlorine dosing, the formation of algae and microorganisms are avoided for up to 1.5 hours. And after 1.5 hours, we have to again add chlorine because the effect of the chlorine dosing previously added gets over. So we have to apply chlorine after 1.5 hours every time. This increases the manual time of the worker, or a temporary worker is needed in order to add chlorine after 1.5 hours. Existing cooling water system. This process shows that the water which has been taken from the Buckingham Canal water and reaches to the cooling water pump house. It undergoes through a process. The first process is that the water which is intake from the Buckingham Canal water from the anode creek, then it is transferred into the trash rack at intake and traveling screens from which the covers and etc. waste materials are removed. Then it is transferred into the cooling water pump house, then to the debris filter, then it is transferred into the condenser, and after doing this work into the condenser, it is transferred into the outlet canal. Seawater as cooling water system. Our aim is to use the pure water instead of polluted water so that the above mentioned causes will not be present, by which the plant load factor will increase. Presently, the cooling water system uses Buckingham Canal water. We cannot use Buckingham Canal water because over 15 years this water has been used and it has been highly polluted. So instead of Buckingham Canal water, our proposed view is that we will use seawater as cooling water system. The seawater can be used in two different ways, namely seawater usage method and reverse osmosis usage method. The main difference between the seawater usage method and the reverse osmosis method is that in seawater usage method we have to use deep seawater in order to circulate it to the condenser, whereas in the reverse osmosis method we can use the seashore water in order to circulate it to the condenser to do its work. Let us see each of the method in details in the next slide. So as I already told, after the analysis of the report of chemical composition of water, we have two different solutions for the improvement of cooling water system in endothermal power station. They are seawater usage method and reverse osmosis usage. Schematic diagram of deep seawater usage method. This process consists of 5 variables or parameters, for which in first we have to use the deep sea water, and we have to bring the deep sea water into the forebay, which we can also call as a reservoir, which is of 15 meter depth, and then it is transferred into the condenser, then it is transferred into the cooling pump, water pump house, then it is transferred into the sea by using the outlet canal. In this one, the underground pipes are made up of RCC material, and the forebay can be formally called as a reservoir, which should be of 15 meter depth. Seawater usage method. So this is the basic idea of seawater usage method. When we use seawater usage method, we suggest that the material of the condenser tube should be titanium. Seawater should be drawn from deep sea inside. Water must be drawn with the help of underground RCC pipes. RCC means reinforced cement concrete. The piping system should be underground system. The water should be brought into force and forebay of 15 meter depth. Then it is transferred into the condenser with the help of pumps. After the work is done, it is transferred into the cooling water pump house, and after that it is sent into the sea again. This process continues again and again. Before using this process, our suggestion is that the condenser tube must be of titanium. Though titanium is highly costly material, but the efficiency of the titanium is far more higher than the other materials which are used, or which can be used, or which are available in the present market. Technical aspects of seawater usage method. Chlorine dosing must be provided in the cooling water suction end. The cooling water forebay, or formally called as a reservoir, should be of 15 meter depth. The cooling water forebay level lowest than 4 meters. Then an alarm should be initiated. During that period, condenser outlet valve is adjusted to 60% from 100% by the operator. Traveling screen should be available at forebay. There should be 3 cooling water pumps, or normally called as booster pumps. The cooling water forebay should be common to 3 cooling water pumps in order to use the water for convenient purposes. Condenser specifications. Height of the condenser should be 3 meters. Water tubes that are present should be 10,000 tubes approximately. There are 3 types of materials which are available in the present market. They are aluminum brass alloy, copper, nickel, titanium. The titanium is the more costly metal than other alloys or metals which are presently available in the market. Titanium is 5 times costly than the other materials which are available in the market, but our suggestion is that titanium is the best material for the condenser tube. Though the cost is slightly high, but there will be no breakdowns when compared to the other materials. When compared to aluminum brass alloy, the aluminum brass alloy can be efficient but not that efficient as that of the titanium. And when we compare it to the cupronickel method, the cupronickel material is 80% efficient, whereas the titanium is about 95% to 96% efficient. So the cost is slightly high, but when we use titanium, we can get 100% efficient, by which we can reduce the number of vehicles and by which we can benefit more than other materials which we use. Boiler tube specifications. This is the boiler tube specifications of a 60 megawatt power plant. The MCR should be 260 tons per hour. The MCR is the main continuous rating, that is the steam produced. That is 260 tons of steam is produced per hour. The rated pressure should be 96 kg per centimeter square. Rated temperature should be 540 degrees centigrade. Maximum water content in the coal should be 10%. The heating surface area is 1500 230 meters square. The coal used here is bituminous coal. The calorific value is 43,000 kilocalorie per kg. The coal used is imported from Odisha, and the shipping charges of the coals are also included, and 1 ton of coal costs 2,000 per kg. But originally in Odisha, the 1 ton of coal costs 600 per kg. Hence the shipping charge also increases. This is gallery. This is the gallery of the thermal power station. On the left side we can see the boiler picture, and on the right side we can see the raw coal, which are used as the insulator, so that the heat transfer to the outside environment reduces. The boiler height is around 36 meters. The chimney height is around 80 meters. Reverse osmosis method. Now, after seeing the seawater uses method, our second suggestion is to use reverse osmosis method. The main difference between the reverse osmosis method and seawater uses method is the intake of water. In reverse osmosis method, the seashore water is used, whereas in seawater uses method, deep sea water is used. The reverse osmosis method consists of 4 main chambers, namely multimedia filter, carbon filter, water softener, and reverse osmosis unit. There are different functions for these four units. In the multimedia filter, the impurities like covers, carry covers, etc. are removed. In the carbon filter, the particles of carbon which are present in the water are removed. Water softener. The water can be classified into 2 types. One is hard water and another is cold water. Hard water can be termed as hard water because it contains several impurities like silt, etc. And soft water means it does not contain any chemicals or silt inside it. And the fourth is about the reverse osmosis unit. In the reverse osmosis unit, there consists of many semi-permeable membranes. But according to our choice, according to our suggestion, we will use a specific semi-permeable membrane so that the cost of the reverse osmosis method will also be low, and we can get efficient production output from this method. This is a diagram of how seawater can be used in reverse osmosis method. This is the layout of the reverse osmosis method. First of all, the water in the forebay is transferred into the filters by the help of booster pump. Then from the multimedia filters it is transferred into the reverse osmosis unit, and from the reverse osmosis unit, after the water is purified, it is transferred into the reservoir. Technical aspects of reverse osmosis plant. Now let us discuss the technical aspects of reverse osmosis plant. Reverse osmosis plant has to clean around 10,000 meter cube of water per hour. An extra forebay of 15-meter depth has to be created so that the water which has been purified to be stored in that 15-meter forebay. The reverse osmosis membrane. There are different types of reverse osmosis membrane like cellulose membrane, polyamide membrane, etc. But we suggest to use polyamide membrane because the pH range of polyamide membrane is wider than the pH range of cellulose membrane. The pH range of cellulose membrane is around 4 to 7, whereas the pH range of polyamide membrane is 4 to 11. Polyamide membrane temperature can withstand up to 35 degrees centigrade, whereas cellulose membrane can withstand temperature up to 28 to 29 degrees centigrade. The cost of the polyamide membrane is less compared to that of the cellulose membrane. The only disadvantages of this membrane is that it cannot withstand chlorine attack, whereas the cellulose membrane can withstand chlorine attack, as well as the cellulose membrane is used vastly in the industrial purpose. The pressure required is 50 to 60 bar. The area required to construct the reverse osmosis plant is 3 years. Annual analysis for the year 2010-2011. Here we have shown some data. On the left hand side we have given the nature of fault, and on the right hand side we have shown the number of days/years unit in shutdown. For turbine, the shutdown took place for 49.54 days. For boiler puncture, it took place for 55.37 days. For condenser, the shutdown took place for 14.57 days. And for chloride pump house, the shutdown took place for 12.38 days. The steel vessel level, the shutdown took for 11.65 days. Other fault, the shutdown took place for 3.3 days, and for debris filter the shutdown took for 3. So at last, conclusion. The main point which we wanted to say that the plant load factor was decreasing year by year, and the efficiency of the plant was also decreasing from year by year, by which the plant was getting less profit in terms of production, in terms of benefits. So we thought we could improve the plant by our suggestions, by our methods, by our researches which we have done with the help of various causes and various problems, various methods. We came to know that cooling water system, the existing cooling water system, was one of the cause by which the plant load factor was on the verge of decreasing day by day, and we suggested for using seawater as a cooling water system so that the pure water, so that the plant load factor will increase by use margin, condenser and boiler tube failures will be minimized, life of every equipment will increase, reliability will increase, the efficiency will increase, and the working hours per year will also increase. Overall, the plant efficiency increases, which is one of the main points for endothermal power station. Because the plant has been working for around 30 or more years, because of which if we take some extra precautions or extra care, then we can maintain the production of electricity of the plant even though the plant works for more than 30 years. So this was, and finally I want to thank Mr. Dilip Raja sir and D. Narayana sir for their inputs by which we can complete our project in time, and hope you have liked it.